Okay, so we are back for 8.5b, the second video. If you've not watched 8.5a, it consists of this slide. We talked about things like communities, biodiversity, species richness, and relative abundance of species. Please make sure you've watched that before you go to the next video, because we are moving on to a formula. We're moving on to a formula that you guys are going to need to know. So let's go ahead and move on here. The formula that you guys need to, what I recommend you pull up a formula sheet, find the Simpsons Diversity Index formula. This is a new formula this year, so this is my first time doing this formula as well. It is called Simpsons Diversity Index, and it's supposed to be a measurement of diversity in an ecosystem or an area, or you could probably even apply this at the biome level, biosphere level. But it's a measure of diversity. So you need to know, you need to be familiar with some of these variables. You guys have seen this before when we did chi-square, the summation symbol right here. We're going to be summing again. Little n, this is equal to the total number of organisms of a particular species. That is important. And big N, loud N, this is the total number of organisms of all species, right? So this is our total. So, as you guys like to know, I like to make a chart up here so that it can help us walk through this step-by-step, similar to how we do with chi-square, similar to how I do population growth and things like that. I like using the chart. So let's go ahead and look at this community right here. Let's look at this first community. We'll call it Community 1. And let's go ahead and try and calculate how diverse this community is. Well, N, if you look over there, is the total number of organisms of a particular species. So, little n, how many total green squares do I have here? You should come up with, let's see, 3. I don't know why my pen is doing this, but it's really bothering me right now. 3. Okay. So, big N represents the total number of organisms of all species. So, out of all species, if we count up all of those squares, circles, triangles, you should come up with 10. 10 is big N. Now, next, you should have seen this before. This should ring some bells. We calculated this on the last slide when we talked about species richness and relative abundance. This is the relative abundance formula, as it were. Okay, so little n over big N. Little n, let's put this here, 3. Over big N, 10. 3 over 10. Okay. So you can convert this to decimal from here if you want to. I think it's better to leave it in fraction form just because we have such simple numbers right here. All right, let's move on to this next step. N over big N squared. All we have to do is take this number and square it. So that should give us 9 out of 100. 9 out of 100. So if you square this, you should get 9 out of 100. Now what I'd like you to do is I'd like you to complete this table for the other species present. Go ahead and pause the video now, and we will come back once it's complete. Okay, so I magically filled out the rest of this chart. It probably just appeared to you guys. Hopefully you went and tried that on your own. I have this finished over here. One of the second to last step we need to do here is we need to add all of these up, right? That's the last thing we do is we add all of these up. So go ahead and pause the video again. Now that you have this chart, you've corrected it, and I'm putting plus signs all the way down here. And this is going to give us our total here, our total of all this. So go ahead and pause, calculate it up, and I'll see you again, and maybe a number will magically appear. Okay, so you should have got 34 out of 100. Of course, I only did this because it was very convenient. I did it in fraction form. But normally, it's probably going to be easier, especially when dealing with big numbers, so just go ahead and convert these to decimals. So I'm going to go ahead and convert this to a decimal. Again, it's an easy decimal to convert. This is also equal to, if you divide 34 divided by 100, you're going to get 0.34. So we have our sum. Is that all we have to do, though? No. We have this 1 minus portion that we need to deal with. So finally, last step, 1 minus 0.34 is equal to. Go ahead and calculate that out. I'll calculate it out with you. Give me a second. This is going to equal 0.66. So this is a measure of diversity. This is the diversity index. So 0.66 is our diversity index for this community. Diversity index. Now, what I'm going to do is pause the video, and I'm going to clean this up. I'm going to erase everything. except for this first calculation for community 1. And I'm just going to put community 1 because we're going to compare diversity. We're going to compare diversity. Community 1. We're going to do, after this one, community 2. Community 2. We're going to calculate the same thing we did here for this other community. So I'm going to, you can go ahead and pause the video and start attempting this on your own, and I will do it with you. Okay, for community 2 down here, let's calculate for community 2. This community 2, where I've drawn this arrow over here. Okay, let's calculate this again. It looks like I left the big N, all the same, 10 individuals total. So let's go ahead and go over to little n here and count the green squares, the species that is the green square. And I have a total of 8 species, or 8 individuals rather. And it's selected. Okay, let me erase that. That's fine. Just fix it here. 8 out of 10. Okay, that's a terrible 8, but you get the idea. Okay, orange triangles. I only count one of those. You guys just count one of those? What about blue circles? I also only count one of those. Okay, so let's go ahead and continue on here. We have 8 out of 10. I'm going to keep it at 8 out of 10 for now. We have 1 out of 10 and 1 out of 10. Let's go ahead and continue. I'm keeping it at 10 because when I square it, I want to have a common denominator ready to go. Again, you might not want to do this fraction form, but that's up to you. Everybody is different. 100 and 1 out of 100. So, next step. I think you guys will agree, 8 out of 10. This gives us a very large number, 64 out of 100. Let's go ahead and add all these up all the way down. 64, 65, 66. So we have 66 out of 100, which is going to give us 0.66. But is this our last step? No. Our last step is to take 1 and subtract this number, 0.66. Is going to equal, oddly enough, 0.34. 0.34. This is going to be our diversity index. Let's put DI over here. For community 2, 0.34. So it's actually the exact same numbers flipped in this scenario. That happens to be a coincidence. This happens to be a coincidence, so don't expect that every time. But if you'll notice, this number 0.34 is much lower than 0.66. The higher the diversity index, as you see in this first population over here, the more diverse it is. And you can really tell, look at community 1. It's a very diverse community. It's got multiple individuals of different species. If you look at community 2, it's kind of dominated by this horrific green square over here, right? It's taking up everything. There's not many of the other species. This kind of helps us judge how diverse a community is. So community 1, 0.66. Community 2, 0.34. That's a measurement of diversity. If you want to calculate this last one, in which we have all green individuals, you can. But it's going to end up being 0, right? There's no diversity to this. Okay, I'm going to go ahead and leave this video at this. I hope you understand the Simpsons Diversity Index. We will get some practice with it. So don't worry, we're going to do a little activity with it. We'll get some practice. So I hope that makes more sense to you. All right, see you next time.